prospects also. Okay, so fine. So I just started recording it. Okay, let's go to the class. So this course is, I think I shared the template, the course outline. So this is quantum chemistry and group theory. It's a 3-credit course. That means it's all theory. So every week we take 3 classes, and for people who have who could not attend the live classes, there is a we have a interactive session weekly once. It's mandated by our institute that ideally everyone should attend the live classes. If someone could not do it because of various reasons, like internet breakdown or for other reasons, for them there is always an interactive session scheduled every week. Okay, so for this class, I think we have mentioned Monday, Wednesday, Friday as 2 o'clock as the regular class. And then the interactive section, those who could not attend or have some problem in attending it, they can always come at 3 o'clock on Wednesday. Okay, we have just updated in the timetable that component. So that is for additional information. So this course, quantum chemistry group theory, myself and Dr. Manoj Pandey will be taking it. So this, as you know, the title says that it is comprising of 2 parts. One is quantum chemistry, and other is group theory. So someone is joining now. Probably inshallah. So 2 parts. So initially I'll start with the group theory. It will go maybe 18 to 20 lectures. Once I finish it, then Dr. Manoj Pandey will start. So this, I think we have given the reference material. See, most of the books are available hard copies in our library. So I don't know how you will access it. Some books I have a soft copy. You can always get it. I can share that document. Okay, the soft copy of the book, whichever I have. If not book, at least the study material I have a soft copy. I can share it. You can use that. Okay. For group theory, we are going to use a book named. So my voice is audible. I have to use the mic. Is it audible?
Yes, sir. Audible.
Yes, sir.
Okay, then I avoid using the mic. I just start speaking. Books. Group theory. So there is a very famous book written by F.A. Cotton. You just search it online. You should get it. F.A. Cotton. Next book is Group Theory in Chemistry by M.S. Gopinathan. And Ramakrishnan. Okay, so these 2 books written by F.A. Cotton and M.S. Gopinathan Ramakrishnan we will follow. In addition to that, there are some study materials which you can refer, which I'll share it. So this book is very reasonably cost. I think you can buy it online, just 100 rupees or something like that. This M.S. Gopinathan and Ramakrishnan book by Group Theory for Chemists. Okay, so about the marks distribution. So we have planned it like there is no midsem exam. Usually we used to have a midsem exam when people are all physical mode. But now since we are all online, so midsem exam is not there. Instead, we will be having quizzes. Okay. So I think in the table we are given the marks distribution. If you have time, you can go through it. But this is there are 3 quizzes of each 20 mark. So ready. This 1, 2, 3, each 20 marks. So first and second I will take. Okay. So it will happen. First one may be happening in October, first or second week. Quiz 2 will happen in November first week. Okay. And then once I finish my syllabus in October, then November onwards, I think Dr. Manoj will start teaching the class. Then he'll take the third quiz. And then in the end, hopefully you'll be back here. I mean, you will be coming to the campus by December first week. Once you are here, and then there'll be NSEM exam for 40 marks. So this was 23, you can say. It becomes 60 marks. And then NSEM. So it will be 40 marks. Okay, so then it becomes 100. So NSEM is for 40. In that also part of group theory will be there, and then quantum chemistry will be there, and then we total for 100 marks. Okay. I think with this, so syllabus, yeah, I'm going to teach group theory. You can find my email ID, phone number, and then website. The way you want to contact, you can always write an email or by phone. You can contact for any queries related to the subject or anything else regarding your MSc. Okay, so let's. Let's start. So this course, I think we started long back, 5 years back. Still, only this course we teach in board. We don't use PowerPoint most of the time for this course because there are too many equations, too many drawings are involved. So we don't use PowerPoint. Instead, we use a board. Actually, we are taking class in this lecture 1. I think I showed you a photograph that has a huge board. I mean, this board is just 1/3 of actual size, but it is very long board. It's very handy for group theory and for teaching group theory and quantum chemistry, because to write huge equations, this board is very handy. So, but with a restricted space, we have to manage, but still it is reasonably good size. Okay, so we'll use the board complete. I mean, whole course we'll be using the board, because some courses I think you must, other faculty may be using the PowerPoint, so that we can just send the PPT to you for reference. But here you have to note it down. Yeah, I just want to inform. Everyone got the email ID, right? Institute email ID. So you always log in using Institute email ID to this group meet, so that we'll avoid the. I mean, every time now people when they come, we have to admit it. If someone is not from IIT Roper email ID, then you have to admit them. Otherwise, they will be standing outside. They cannot join the meeting. So I recommend for it's a must. You should log in with IIT Roper email, so that it's automatically you can join the meeting. Okay, so that is one. And since we are all going to work in the board, and this group theory particularly involves drawing the structures, and then after drawing the structures, you have to imagine, rotate the molecule, apply a plane, and then find out its properties or find out its symmetries. So it needs a little bit of paperwork. So while sitting in the class, while attending this class, you sit with a paper and pencil, or paper and notebook. Okay, paper and pen. Okay, and it is recommended you take notes also. Although we record it and send it to you, but you have to note it down. What are we attending in the class? You NRV, which are you need to note it down. Please note it down. So that's why, at least particularly for the group theory and quantum chemistry, you need paper and pen. Okay, so just note it down. And of course, yeah, lecture notes we are going to send it, but still that is only for a backup plan. Okay, so far any question? Is it okay? I hope all are live. I mean, all are sitting in front of the computer or
Yes, sir.
mobile. Yeah, Naina Goyal, is it okay?
Yes, sir.
Yes, sir.
Yes, sir. Okay.
Yes, okay. So please have a notebook or paper and sit with pen and pencil, okay? Pen or pencil. So let's start with group theory. So group theory is actually basically it's a mathematical concepts. Mostly it is used by the mathematicians, but for chemical applications, the chemists use a certain part of group theory, or the subset of group theory is used by chemists to understand the molecular symmetries or molecular to understand the electronic structure and molecular symmetries. Group theory is used by the chemist. Okay, so as you know, for a given molecule, you have to, if you know the structure of the molecule, the geometry of the molecule and its electronic structure, if you know these two information, then you can get an idea about the properties of the molecule, like its physical properties and chemical properties. You can obtain if you know the geometry of the molecule and also its electronic structure. Electronic structure means its orbital pictures. Okay, so if you know these two information, you can get the you can know about the properties of the system, like physical and chemical properties. So group theory is an imaginative science. It's considered as an imaginative science. So from group theory, you can find out imaginative, you can say predictive science also. Group theory is basically predictive science. You can predict. Mostly it is useful in one is it has a direct application in spectroscopy, like which vibration will be IR active, which will be Raman active. Those can be predicted from the symmetry involved in the group theory. So it's a predictive science. One can predict it using this. Also, it gives the symmetries of electronic structure. Like one can know the symmetries of orbitals and then vibrational modes. So one can find out symmetries. Symmetries of various orbitals, the nuclear motion, electronic motion. So these things you can predict it using group theory. And also you must have studied, or you may be studying what is called as Woodman-Hoffmann rules, photochemical reactions or thermal reactions, which reaction is thermally allowed or photochemical allowed. Those are all given by Woodman-Hoffmann rules. So those concepts all involve group theory. So basically, it correlates. The group theory helps to correlate the reactant to product, reactant orbitals with the product orbitals, whether thermally or photochemically feasible or not. So group theory basically enables these things. So as I said, Group theory is a predictive science, and you can find out spectroscopic properties or symmetries. And then reaction prediction. Reaction, we can say, enables correlate orbitals. Reactants and products. Okay, so I think with this applications of group theory, chemical applications of group theory, let's go to the we study what is called as symmetry, and then we study what is called as symmetry element and symmetry operation. Okay, so. So how many of you have studied group theory earlier? Have you heard about this group theory earlier?
Yes, sir.
Yes, sir.
Yeah, can you repeat? Somebody said something.
Yes, sir. I studied
You have
my
studied.
bachelor's.
Okay. How far? I mean, what did you study in group theory?
Symmetry, crystal field theory, Ligand field theory, all.
कुछ समझ नहीं आ रहा है. Point group. Have you guys gone through what is called a point group?
Yes, sir.
Yes, sir. Yes, sir.
Most of you. So how do you know? How do you get that point group?
By symmetry elements.
So we perform symmetry operations.
Okay, symmetry. Yes. Okay. So every molecule in chemistry, one can give classify with a point group. So there are ways of classification. So higher if the molecule has higher symmetry, you'll have a very high number of symmetry elements, or it's possible operations are all possible. If the molecule is not having any symmetry or very less symmetry, then also the molecule will have point group. But from the point group, one can know like how symmetric the molecule is. So from that, one can correlate to the spectroscopy. So point group is important in it has application in spectroscopy. So we'll see. I don't know how much of if everyone has studied it, then we can go quickly. Just let me know after 1 or 2 class. Let me know if it is whether it's all repeating or it's something is new. Okay. Okay, so let's start it. Maybe a basic class, 1 or 2 class, maybe a basic, or you might have already studied. If it is kind of repeating, we'll just speed up the things and then finish it. Yeah. Okay. So symmetry. So symmetry means there is a relation between parts of an object with respect to size, shape, and position. That's called as symmetry technically. Symmetry element means it's a geometrical entity. So it's a symmetry element is a geometrical entity. So geometrical entity means it could be a point, it could be a line, or a plane. Okay, a point, a line, or a plane. So in a molecule, you can have symmetry elements. So So what a symmetry element means, it could be a point, a line on plane. Whether you, based on this entity, you can find out symmetry of the molecule. So that's why it's called symmetry elements. Symmetry operation means, name per se, it's an operation. So operation or operator, which performs certain action, right? Operator means it just performs and acts on a 3D object. So it's an operation. Acts on the object. So it's operation means you just perform certain operations. Like in mathematical operation, algebraic operation, what do you say? We just say plus, minus, multiplication, division. So these are all mathematical operators. Whereas in symmetry operation, we have different types. So one is one you can say it's a rotation. So first type is rotation, and then you can say it's another one is a mirror plane. The third is inversion. And last one, or fourth one, is improper rotation. Improper rotation means cutting, right? And the last one, or it's every molecule will have these operators valid, and there is an operator called identity. Okay, so that's every molecule will have a property called identity, like doing nothing, just staying as such. So that is itself is one symmetry. And rotation means if you rotate a molecule into various angles, you will get back its original, you will get back its similar structure or identical image, identical structure. So that is rotation. If you apply a plane on the molecule and then if it gives a mirror image of that, then you call it as a mirror plane operation. And then inversion means from a center point of a molecule, if you go in various directions, you will reach equivalent atoms. So that then you call it as an inversion. Improper rotation, I'll explain it. Improper rotation is a combination of two operations. One is rotation followed by a mirror plane. If you do that and if the molecule is giving back its mirror image, then you say it is having improper rotation operator. Okay, so these are the different types, and people have given symbol for each.
So
Yes.
so whatever you are writing at the corners of the board is not visible.
So this is not visible, huh?
Yes, sir.
Plane is visible, plane is visible. Improper rotation.
Okay, sir. Thank you, sir.
Okay, I'll change this line. It could be a line. I change the location. Fix this as our border. Huh? So identity has symbol. What is the symbol of identity? Any one of you?
E or I, sir.
It's going to be a symbol E. Okay. So as I said, it is doing nothing. I mean, for every molecule, this symmetry element or symmetry operation will be present. Okay. So this is identity. Second is rotation, given by symbol C. Generally, it's given by symbol subscript. I would say just give it a C1. C symbol. for rotation. So it is given in terms of 2 pi by n. So 2 pi is 360 degrees, and then n is basically n-fold of symmetry. N stands for n-fold symmetry. Or n-fold rotation also you can say. N-fold rotation. Basically, if you take a molecule, for example, any molecule, can you give me? Maybe we just start with which one? Benzene or water. Water we can take. So H2O. So if you draw water, so you can say it has what? To put a line through this board, and then you can rotate this molecule, right? So you can say this is H1 and this is H2. For water molecule, if you rotate it by certain degrees, you will get back the identical image, right? So if you rotate it, say by 180 degrees, so what do you get? So oxygen will be present there itself, and then this H will go. H1 will become H2, whereas H2 will become H1 by rotation. Yeah, so we are rotating by 180 degrees through this certain axis. It is passing through atom oxygen O. Just imagine water is it's on the plane of this board, and then you are rotating the molecule by 180 degrees, and then what you will get? You get an indistinguishable image, right? So you will get the equivalent position. Only thing is the atoms are interchanged. The hydrogen atoms labeled by H1 and H2 has been interchanged. So this is here you call it as 2 pi by 2 pi is 360. N is 2. Okay, we'll end up in 180 degrees. So here N is 2 here. So N is 2. So water molecule has two-fold rotational symmetry. So like this one can say, if you take benzene molecule, what will be the N? I take this benzene molecule. So I just want to find out what is the N for benzene. The maximum.
6.
So there are multiple N also, but
66.
molecule. 6 is the maximum number.
Yes, sir.
Okay, so N is 6. Any other number possible in benzene?
3, 2,
2, 2,
3
Everything is
and
possible.
2 also.
3.
But the principal axis will be say 6.
Yes. So if you have a benzene molecule on a flat plane like this, if the axis passes through the molecule, and then you can rotate 6 times, right, to get the identical image. So N is having. So this is 1 and 3 and 2. How it is? So you place the molecule on this board, and then you can rotate it by what? You can rotate it by 120 degrees. Then you will get the indistinguishable image, equivalent image. You will get it 3 times. You will get 120, 120, 120. So rotate 3 times, so you will get back its original shape. But for every 120 degree, you will get the equivalent structure. And also N equal to 2, right? N equal to 2. How it is possible? You can rotate through this angle. The molecule is on this board, and then you can rotate it. So these 2 atoms can go this side, and these 2 atoms can come this side. Yeah. So you can just flip it. 180 degrees flipping, you can do it. So that is N equal to 2. So all 3 possibilities are there. So these are all called as axis of rotation or rotational axis. N having maximum number is called as principal axis. Okay. So in benzene there are multiple rotational axes present, and N is having maximum. In benzene is 6. So that is called as principal axis of rotation. Okay. Whereas in water molecule, which we considered earlier, doesn't have, it has only one rotational axis. So we call that one as a principal axis. Okay, nothing else. Whereas in benzene molecule or other similar molecules, like even the square planar complexes, like PTCl4, if you take, it is a square planar. So there also you have multiple axes of symmetry, axis of rotational symmetry, and n will be different. So maximum n is called as principal axis, and n is maximum. It's called as principal axis of symmetry. Principal or principal, I don't know. That's the principal axis. Okay. So can you tell me for ammonia molecule what will be the axis of rotation?
C3.
C3. C3.
3. Okay. Good. So to represent that, we call by the symbol Cn. Okay, so this n is given in terms of a subscript. This is one way. Cn. What else? Cn, and then. So most of the time we mention this is C6 or C3 or C2, like that it's mentioned. Okay, so like that one can write. Okay. It's called very dark. I think we have a sensor in the room. I hope it is because of that. Yes. Okay, so we are in a modern classroom. So if there is no movement, what happens is just the lights are all getting switched off. So other part of the room got switched off because of sensor. So this is about the rotation. So those who have studied, say to represent, there are multiple C6, like in benzene we consider, right? So this is benzene molecule. So if you can label like 1, 2, 3, 4, 5, 6. So you can rotate it by 60 degrees. So what happens? So this goes to next structure, right? So the one goes to the 1, 2, 3, 4, 5, 6. So this one is C6, kind of superscript is 1, or we don't really write 1. But this structure, since rotated by 60 degrees, it is written as C6, 2. Okay, C6, 6 is subscript, and 2 is superscript. So like this, one can keep writing it. So it's possible various for C6. It's possible C6, C6, 2, C6, 3, C6, 4, C6, 5, and C6, 6, which is nothing but E. We are coming back to the original structure. So this is so like that one can keep on writing C6, 2, C6, 3, C6, 4, C6, 5, C6, 6 to represent how many times you have got the indistinguishable image. Okay, so this is all about the rotational symmetry. Okay, shall I go to the next topic, next operation? Third is what? Mirror plane. So what is the symbol for mirror plane?
Sigma.
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 Yes?
Sigma.
Sigma, okay. So what are the possible mirror planes in the molecule?
Horizontal, vertical.
Vertical, horizontal, dihedral.
It is sigma H and sigma D. Okay, so basically mirror plane is the molecule is reflected through a plane to get indistinguishable image. Okay. So that is a mirror plane. So we can take simple example. Shall we start with a simple plane? So let's start with water molecule. Yeah, simple example. Think that molecule is on this plane of this board. Okay, so the water molecule is placed on this plane of this board. Um, so what plane is possible in this sigma? Sigma V means is a vertical plane. H means a horizontal plane, and D is a diagonal plane. So sigma V is basically which is a plane of symmetry passing through along the axis,
Principal axis.
along the principal axis. So that is called as sigma V plane. So this is sigma V is a plane of symmetry along the or you can say principal axis. Sigma V. So in water molecule it has only one axis. So this is one plane. So you could keep a mirror like this. So we can say this is C2, right? Water molecule is having C2 symmetry, C2 rotational axis, and keep a mirror on that. So then this H will be replaced by H1 becomes so H will come to here, H1 will come to this side, and H2 will come to this side. Keep a mirror. So basically we get the indistinguishable image by placing a mirror on this axis. So that is a parallel. So water molecule will have sigma V plane. Okay, and also it has another. Okay, so I don't want to go to another sigma V. You can place the molecule, or you can place a mirror this direction also across this board. Okay, so if the molecule is placed on this plane of this board, and then say you are just cutting the board into two. So if you place it in this fashion, if you cut it, what happens? All three atoms will be cut into half. So that is also another plane. So people call it this. Still, it is again along the axis of symmetry, along the principal axis or this axis of symmetry. So this is called as sigma V plane. Okay, so one is cutting the molecule. This again along the principal axis, and other plane is across the water molecule to cut. Will give the indistinguishable image or symmetric image in you. So that is also called as sigma V. But to differentiate this with this, it is given by symbol sigma V prime. Okay. So water molecule will have these are the symmetry elements. So water will consider what are the symmetry elements present. Then E is possible. That's identity. Every molecule will have E. And then C2 is there, which we saw for water. And then sigma V and sigma V prime. Okay, so these are the three or four symmetry operations possible for water molecule. So symmetry elements are identity, rotational symmetry, and mirror plane, vertical mirror plane. So okay, so I think this is clear, right? So I'll give you one assignment for ammonia molecule to find out what are the symmetry elements. Okay. I hope you didn't sleep. After lunch, you are all sitting. Huh? It's weird to talk to a computer screen. Huh? Anyway, we did this actually last time after the midsum of last semester. Your seniors, MSc students, we took physical classes till March 15th. After that, they went home because of midsum break, and then we have to shift to the online mode completely. So now we used to this, used to talking to a monitor. Anyway, fine. So sigma h. Let's go to the sigma h. So sigma h is as the h stands for horizontal. So it is if the plane perpendicular to the principal axis is given by this sigma h symbol. Okay. So this is for plane of symmetry. Perpendicular. To principal axis or axis of symmetry, you can say. Mostly it's principal axis. Okay, given by symbol sigma h. Yes, any example for sigma h? Any
PTCl4 2 negative.
Huh?
PTCl4 2 negative, or any symmetrical square plane molecule.
Okay, you are talking very difficult molecule. I just choose benzene. Okay, so this molecule has sigma h plane. Okay, so it has so principal axis is this side, right? If you place the molecule on the board, and then you can we just saw the molecule can if I put a dotted lines, it is just going from this side of the board to the other side of the board. Okay, so it's perpendicular travel. So if you go like this, so that is C6 symmetry we have in benzene. Whereas you place a mirror on this board. So you just place a mirror on this board, so you cut the molecule into half, right? So, so if you consider that, then this molecule has sigma h plane of symmetry, meaning you are just cutting the axis. So the principal axis is going like this, whereas you are placing a mirror to cut this molecule. So that is called a sigma h. Any square planar molecule will have sigma h. Okay, so this is a good example for sigma h. And then water doesn't have, ammonia doesn't have, because they have only sigma b plane. They don't have sigma h. Okay. So this is you think about, come maybe for next class, you think about some other molecule which have sigma h plane. Okay, every one of you, not just 2 or 3 people who have studied group theory, but other people also. Just come up with some examples which has sigma h plane. Okay. So we are still in mirror plane now. So there is something called sigma d. The name suggests d means it's a diagonal. Sigma diagonal. So its definition is basically if a molecule, if a plane bisects an angle between 3 atoms, then it is called as a sigma d. Different books give different definition for sigma d, but they mean the same. So what it does is one definition is if the molecule has 2 sigma b planes, and then if you can bisect the 2 sigma b planes, then that plane of symmetry is called as sigma d. So one definition is plane passing through 3 atoms. Bisecting plane. Okay, so it's not actually passing through plane, bisecting angle between 3 atoms. Is one definition, or another definition is plane bisecting 2 sigma b planes. Yeah. So if the molecule has 2 sigma b, like sigma and sigma b prime, and if you put another plane which bisects these 2, that is also called as sigma d. So what it does is basically it has it just passes through 3 atoms. So that's what the definition is. A good example is XCX4. The molecule XC F4 has sigma d symmetry. Okay, we'll see this in next class. Just you can try it out how it is having sigma d. So it has sigma b, sigma h. It has 2 sigma b, then sigma h it has, and then the sigma d also is there. So structure you must be knowing, right? It is a exam qualified chemist, so structure is knowing. So for this molecule, it has all. V is there, sigma h is there, sigma d is there. Okay. I think I'm running short of time. I think I'll stop it here. I think you may be going for another class or. Okay, it's time up. I think I'll stop it here. Okay. Any questions so far? So this we have done it. This we have done it. This we have done it. Other two will just continue in next class. Okay. So what I'll do is I'll just save this video and then record it to the. I'll save it in the Google Drive. Then I'll send the link. You can access the video. Okay. You start reading it. Also, if there are some study material, I have a document of study material for group theory. I will send by email. Okay. So, so any other question? Let me see the chat box. Okay, some of them now studied. Good. So for those who are new, yes, you have to learn. It's good. So let's see how there's a mix of students. I know every year we see some universities teach group theory, whereas most of the universities do not cover group theory in your BSc. So uniformly will cover. Okay. So you start learning group theory. We'll give the study material. We'll give the recorded lectures. Then yes, you can study. Okay, this will be useful in spectroscopy and other applications. So thank you. We'll meet on Monday afternoon, 2 o'clock. So I have to stop this recording.